So happy Wednesday, ladies and gentlemen. Distance and time graphs and motion notes today. You have that quiz today as well. The essential question: how can the motion of an object be interpreted from distance and time motion graphs? Our learning targets: I can set up a distance time graph correctly. I can explain the speed of an object by interpreting the line on a distance time graph. And I can use distance time graph to make predictions and calculate speed of the object. So graphing motion, the motion of an object over a period of time. So let's take a look at what we have here. So this is my y-axis. This is my x-axis. And typically we have, this is the 0 point, and then we count off in seconds, and a lot of times it'll go 1, 2, 3, 4, and then meters might be the same thing, might go by tens or same units, 1, 2, 3, 4 meters. So remember, when we plot something, we go x, so we go left and right first, then we go y. So in this particular case, this point here would be 3. We didn't want to do that 3, 3. So that's the x and that's the y. Let's do this one. No, they're all going to be about the same. So let's do this point here. It's off the graph. So this is 3, 5, 3, 5. So just to review, this is the origin. This is a straight line. A straight diagonal line is created when an object is moving at constant speed. Okay, so we're looking at constant speed here. A little bit bigger pen. Here we go. Constant speed. So the steepness of the slope makes a difference as far as the speed. Just by looking at it, the object is traveling at a greater distance in a shorter amount of time. So the slope, how steep it is, shows that this blue line is faster than the red line. So just by looking at the slope, we can tell. So other things that we've talked about before. So in our moving person experiment or app, or simulation, I should say. So here, the object has stopped at the top. So it was moving at a constant speed between A and B, let's say, but between B and C, it stopped. Now, the blue line is going to be higher speed, but it still stops up here. So the slope is 0, and remember, the slope, when we're looking at the slope, we look at the rise over the run. So here there is no rise. There is no up and down component. So we say it stopped. A straight diagonal line that has a negative slope is going, or downhill is created when the object is going the opposite direction. So remember, in our moving man, To the right was positive, and to the left, going back, was negative. So this was going backwards. So going back to the starting point here, constant speed here, going to the right, stopping here. So this is how you can interpret the graphs. All right. A curved line in a distance time graph indicates a changing speed. Curved lines mean acceleration. So we haven't talked about that yet. Now remember, in acceleration, so if we were to take a look at constant speed looks like this. One dot in front of the other, same distance apart. You're walking same speed. Your car is going not faster or slower, but in acceleration, the dots get further and further apart from each other. And when we graph that, that's how we get this curved line. A curve downward is negative, so the black line is a negative acceleration or slowing down. A curved line in the curved upward is speeding up. So think about it, your car leaving a stop sign, speeding up. If we were to graph that, that would be the positive for acceleration, pushes you back in your seat. Where you're stopping or slowing down, you can feel yourself being pushed forward. Right. Speed can be found using the points on the distance time graph. So in this particular case, distance 2 minus distance 1. So here we're looking for the speed in the trip at portion C. So here is, if we look at the graph, this is 50. This is 20. So we put that up at the top here. 50 minus 20 is 30. And then the the change in speed. So this is 6, and this is 5. 6 minus 5 is 1, so 30 over 1, or 30 meters per second. So, and that's how we find that's also how we find the rise. So the rise in this particular case would be 3 over 1. So the slope would be 3, but we interpret it using the distance and the time here. So let's take a look at this graph and find the slope of certain points. So again, we can start at a starting point. Here's 0, 0. And we look for a point that crosses right in the middle. All right, so this particular one, we have, so my final is 5 minus 0 for the meters. And my 3 minus 0 is 3. So 5 over 3 is my slope. So 5 meters in 3 seconds. Now, if we would want to divide this, so we have So in this particular case, we want to make it so it's in per second. So 3 goes into 5 one time, 3, 30, 20 left over. 3 goes into 26 times, and it's going to be repeating. So this is 16 meters per second, 16.6. So let's check our understanding. To draw a distance time graph, label the axis, right? So distance here, time here, put the numbers in. This is my y-axis and my x-axis. All right, check your understanding. Describe the motion of the current object during the trip in position A. So position A, that's a constant speed. And that's in the positive direction, so to the right. Motion of the object during the trip portion of D. So D, so that's stopped. And which portion of the object traveling? Which portion is the object traveling at the greatest speed? All right, so that would be at C because it's steeper here. So if we look at the slope here, 3 over 1. Here it's 1 over 1. The rise, 3. The run, 1. All right, so let's answer some questions. How long has the object been stopped during the portion of B? So if we look at this, from 2 to 3, so 2 to 5, so that's 3 seconds. What is the total distance the object traveled? So it went from 0 to 60 meters. Calculate the speed at portion E. All right, so the speed at portion E, so here is, it went from 50 to 60. So 60 minus 50 is 10. And it did that in 8 to 11, 3 seconds. So 3 goes into 10 3 times, or 3.3 meters per second. Calculate the average speed for the entire trip. So it went 60 meters in 11 seconds. So 11, let me do it over here. 11 into 60 is 5. 55. 5 left over. 5.5 meters per second. Average speed. Okay. So that's it for this slide presentation. Thanks.